Okay, welcome back. Happy Monday. Today is class number 23. Today, the pipeline project is due, so throw it in the folder if you have it. I do take projects late, but there are various penalties associated with turning them in late, so turn them in as soon as you can. Today, we're going to go over, we're going to do an overview of derivatives. Remember, last class, we saw our very last derivative rules of the whole semester, so today we'll kind of summarize everything we've done and do some complicated derivatives together. Coming up later this week, Wednesday is our review for test number 2. Our test is on Friday. Also coming up this week, tomorrow is advising day here at GCC, so hopefully you've made an appointment to meet with your advisor. Otherwise, you can try to do that soon. If you don't know who your advisor is, see me after class and I'll look it up for you. There are no day classes meeting tomorrow, but evening classes meet as scheduled. Any questions on the schedule? Okay. So again, on page 47, we'll start at the top. Today is all about practicing with our new derivative formulas to find derivatives of complex functions. Number 1, let's have a quick look at the strategy guide below. We begin with a pop quiz, but it's not graded. Let's see how many of the derivative formulas you can remember. Go ahead and take maybe a minute and a half to fill in that bottom row. Then we'll come back together. This is an individual thing, so don't work with your neighbors on this part. Okay, so hopefully we did all right on the filling in the derivative rules. Those are our basic rules. Reading from right below the table, if a function doesn't look exactly like one of these functions, then we can't use these formulas. Instead, we need to use one or more of the following 5 rules to break our function down until it looks like one of the formulas above. So to be clear, the number of things that we can actually take a derivative of directly is really small. It's that table. That's the entirety of the things that we know how to take derivatives of fundamentally. Everything else that we can take a derivative of is going to be combinations of those exact functions in the table. So my recommendation is that you look for things in the following order. So we got 5 things we're looking for, and I recommend you look for them in this order. First of all, is it a sum or a difference of 2 or more of the functions in the table? Right, we're looking for pluses and minuses between things in the table. If so, we can take the derivatives all separately and then add or subtract at the end. It's a rule that we apply without even thinking about it, right? So we might not even be aware that we're applying it, but for example, anytime you see something like 3x squared minus 8x, and you say, oh, 6x minus 8, you're doing the plus or minus rule, right? You did 2 completely independent derivatives, and then you subtracted them at the end. Okay, after that, we're looking for constant multiples. The derivative of a constant times a function is the constant times the derivative of the function. I did that up here. What's the derivative of 3x squared? It's 6x, but you did a constant multiple rule. What is it really? It's 3 times the derivative of x squared, right? So you know the constant multiple rule so well that you might forget that you are applying it. And so you just got to be careful, you know, like there's a real big difference between that 3 there and this 3 over here. And we know it really well for polynomials, but sometimes we get stumped when the functions are a little bit more complicated. Okay, so we're looking for a constant multiple times some things with x's in it. The product rule, we've got the rule written out there for you. Does the function consist of 2 functions which are multiplied together? Actually, should be a little bit more explicit. 2 functions with x's in them. Something with x times something else with x. That's what we're looking for the product rule. Remember, the derivative of f times g is not f prime times g prime. Another caution, cosine 3x is not a product rule. That is cosine of 3x, right? There's no multiplication with the cosine function. And let's take a look now. Next up is a quotient rule. Here we're looking for 2 functions on top of each other, again, both of which are functions of x. First caution, the derivative of f over g is not f prime over g prime. It's far more complicated. And let's move on to the next page, which is the big one, the chain rule. So we've got our derivative formula written out for the chain rule in 2 ways, the composition of functions way and then the Leibniz notation way. So what are we looking for here? Well, if nothing in the above set of rules helped us, then maybe it is a chain rule. Does the function contain a simpler function? Is there an inside and an outside function? What to do? Either you identify the embedded and overriding functions, or you introduce a new variable. We didn't really do this Z thing very often. I think it was once in the set of activities. And then you apply your rule. First caution, for this to work, when you substitute in Z, you can't have any of the original variable left. Again, we don't do that very often. And caution number 2, if there's a composition inside a product or quotient, you got to make sure you do the product or quotient first and then let the composition happen whenever you're supposed to take the derivative of that piece of it. Okay, so number 2 is a big old chart. This examples for strategy guide for differentiation. So for example, x to the 5th plus sine of x, what do we notice first? It's sum rule, right? That is two things added together, so we just do them completely separately. 3x to the 5th, what do we notice? It's a constant multiple, 3 times. So that 3 stays when you take a derivative, just waits until you've done your derivative and then you multiply by 3 at the end. What rule here for x to the 5th sine x? That's a product rule. X to the 5th over sine of x. That's a quotient rule. All right, how about sine of x to the 5th? That's a chain rule. What's the inside function there? X to the 5th. So then the overarching thing that I see in this one is sine of stuff. Yes? How about sine of x all to the 5th? That's also chain rule, but it's not sine of stuff. What is this? Stuff to the 5th. Right? See the difference? Really important to identify inside function, outside function. Okay, next one is going to have several rules. What's the overarching rule? That's a quotient rule. In the midst of doing the quotient rule, you're going to take the derivative of the bottom. What rule is that? That's a product rule, okay? Next one, e to the x sine of 5x. What's the first rule, overarching? That is a product rule. In the midst of doing that product, you're going to have sine of 5x. What is that? That's a chain rule, sine of stuff. Yeah? Okay, and in the last example, ln of x to the 5th cosine x. What's the first rule? Use the word stuff. That is ln of some stuff. And then when you take the derivative of the stuff, what rule will you use? Yeah, the 1 over stuff is the ln. But in taking the derivative of the stuff, what rule is that? That is a product rule. Okay. All right, so you can take a look at the details later if you're interested. For now, let's move on to the next page. We're going to do 2 differentiation problems together here. We'll start with part A. G of x equals the square root of 2 to the x ln x. Let's give this a shot. All right, this thing right here is a chain rule. It's the square root of 2 to some stuff. Do you recognize the square root of 2 to the stuff is one of the rules in the chart that you just filled in? Which one is this? A to the x. That's what you have to recognize, is like, what's the basic derivative rule? So I'll put it here just so we remember it, because this one we don't have as much experience with. What's the derivative of a to the x? That's a to the x times ln of a. So g prime of x equals. Okay, so we got square root of 2 to some stuff. So a to the x stays a to the x. So this guy stays square root of 2 to the x ln x. What's next? Times ln of the square root of 2, right? That's the ln of a part. So we've done the basic a to the x rule, except it wasn't x, it was more complicated. It was a bunch of stuff. And so then the chain rule comes in and says, okay, now we're going to multiply by the derivative of all of the stuff. I'm going to put this here. So the derivative of the stuff, what rule for x ln x? That's a product rule. So big old product rule calculation here. So product rule, first times derivative of the second. First times, what's the derivative of the second? is 1 over x. It will simplify to 1. Product rule continues, plus the second ln of x times derivative of the first, 1. Yeah, 1 plus ln of x is pretty much the only thing we can do here. 1 plus ln x is what simplifies in the parentheses. Questions on that one? Okay, let's try part B. E to the cosine of ln of x squared plus 1. What's the overarching rule for this one? This is the e to the x rule, right? It's e to some stuff. So I don't think we need to write that one. We know it pretty well. Y prime equals. Okay, derivative of e to the x, it's e to the x. So the derivative of e to the cosine of ln of x squared plus 1 is e to the cosine of ln of x squared plus 1. Copy the entire thing. Times the derivative of the stuff. I'm going to highlight in yellow. There's the stuff. And that stuff is of the form cosine of some stuff, yes? So what's the derivative of cosine of stuff? Negative sine of stuff. All right, I don't have enough room here, so I'm just going to continue. Negative sine of ln x squared plus 1. Okay, and now times the derivative of that. We just did cosine of stuff, so the new stuff is right in there. Okay, so times 1 over x squared plus 1. Right, ln of stuff is 1 over the stuff times the derivative of the stuff. What's the last stuff? The stuff itself is what? Is this x squared plus 1. And so then finally multiply by the derivative of that, which is 2x. So this was multiple chain rules embedded inside each other. Questions on that? Okay, at the bottom of this page, it says, your group activities for today and your homework for tonight is going to be 1 to 73 odd, which is on a certain number of pages in your book. Honestly, I think that's the 6th edition stuff, but anyway, I photocopied it on the next page. So regardless of which edition, you should be able to use the very next page. It may take a few days to get through this assignment. The goal for this week is to prepare for the test. So like, don't stress about doing, however many 37 problems or whatever that is. Like, the goal is to prepare for the test. So I want you to do enough of these things to prepare for the test. In order to get full credit for this assignment, I think it says it someplace, I just need you to do at least 20 of those. So I'm giving you lots of practice. If you can do all the odd ones in there, great, but at least 20 for full credit on the homework as I walk around. There's also an answer key photocopied right after the problems itself, but you might find it more helpful to check answers with your neighbors. Some of you I know have experienced that the answers in the key sometimes are really, really simplified, and it's hard to make your answer look like that one. I'm not worried about simplifying today. So like, just taking a derivative and checking with your neighbor might be better than checking the key, okay? All right, so for the rest of this class, you're just doing your homework, which is photocopied on the next page, just doing odd numbered questions. I will walk around.